Assembly of the obstacle avoider board. Components required: 2 small C-bar, 1 medium plate, 2 small bar, 2 small shaft, 4 wheels, 2 DC motor and 2 IR sensor. First we will take 2 small C-bar and 1 medium plate. Connect the C-bar to the medium plate in this way. The first of all the medium plate should connect to the third hole of the small C-bar and the last hole of the medium plate should be connected to the seventh hole of the C-bar. Now connect the ball and fix it using a nut. Similarly, connect the other C-bar in this way. Now take 2 DC motor and attach each DC motor to the small C-bar. Attach the shaft of the DC motor to the first hole of the C-bar and fix it using the balls. After connecting the motors on both the sides of the C-bar, now take 2 wheels and attach each wheel to the shaft of the motor and fix it using axle lock. After connecting the wheels, now take 2 small shafts. Attach the small shaft to the C-bar in this way to the first hole of the C-bar. And fix the other end of the shaft using an axle lock. After connecting the shaft on both the sides of the C-bar, now take 2 wheels and connect the wheel to the metal shaft and in this way. And fix it using axle lock. We have taken 2 small bars and we have placed it here in the C-bar and connected it using nut and bolt on each side. Similarly, connect this small bar on this side and fix it using nut and bolt. We have connected the small bars in this way. I connect the bolt in this way. Otherwise, the axle lock will get stuck. Now to take 2 IR sensor and connect this IR sensor to the 2 small bars. We have connected the IR sensors. With that, the assembly of our obstacle avoider board is completed. Coding for the obstacle avoider board. In the Arduino block, first select the structure. Select the setup and loop structure. In the obstacle avoider board, we are using 2 IR sensors. So for that, we need to create 2 variables. Click on variable and click on create variable and name it as IRL and IRR. So after creating the variable, select the block set variable IRL. Change the type to integer and from that select the value 0. Duplicate it for the IRR variable. So we are initially the variable will be at 0. Now again from variable select the block put variable IRL and from input output select the block digital input pin. Again duplicate it and for change the variable to IRR. We are connecting the left IR sensor to pin 15 of the controller and the left IR sensor to pin 16 of the controller. Now from these 2 blocks, the IRL variable will store the value from the digital pin 15 and the IRR variable will store the value from digital pin 16. Now from logic, we will select the if block and attach the else block there. Now, if our bot is detecting any obstacle, it will turn backward and will take a turn. And if there is no obstacle, it will keep on moving forward. So when both the IR sensor will detect obstacle, it will give value 0. So for that, from logic, select the AND block and the equal to operator. Place the equal to operator on the first block of the AND block, duplicate it and then place on the second block of the AND block. Now from variable, select IRL variable and put it on the first block of the equal operator. Duplicate it and put it on the second block of the first block of the second equal to operator. Both the IR sensor should give 0 value. So when it is detecting object, both the IR sensors are giving 0 value, our bot will move backward. Coding for obstacle avoider, first of all open the arduino block. Then from structure, select the setup loop structure. From variable, click on create variable as we are going to create 2 variables for the 2 IR sensor. We are naming them as IRR and IRL. So first, use the block set variable IRL inside the block, change its type to integer, and from math select the 0 block. So here we are initializing the IRL variable to 0. Similarly do it for the IRR. Then again from variable, select the block, put the variable, and then from input output select the block digital input pin. Since our left IR sensor is connected to pin 15 of the controller, so give the pin number as 15. So here the data from the IR sensor connected to pin 15 will be stored in the IRL variable. Similarly do it for the another IR sensor which is connected to pin 16, and this variable will be stored in the IRR. So the IR sensor connected to the left side is stored in the IRL, and the IR sensor's value connected to the right side will be stored in the IRR variable. Now from logic, select the if condition, and since there are 2 IR sensors, we are using the AND block. So inside the AND block, give the equal operator block for each IR sensor. So from variable, select IRL, place it here, and IRR. So the first condition is that if both the sensor is detecting object, that means if both IRR is 0 and IR is 0, we are going to use the analog output pin since we are going to control the speed of the motor. Use the block analog output pin, duplicate it 4 times for the 2 motors. Give the pin number as 2 and 3 for the motor connected to the M1 port and 4 and 5 for the motor connected to the M2 port. Here, when there is object in front of the bot will move backward. So here we have to make pin 3 high and pin 5 high to move our bot backward. Then we will give a delay of 1 second. So from time, select delay 1 second, and then we will make our bot move left. For that we will make pin 3 high and pin 4 high. So just duplicate the block. One second. So this is the output when there is the object in front of our bot. So when it will detect an object, it will move back and then it will take a turn. Now we will give an else condition that when there is object in front of our bot, then our bot will move forward. For that we will make pin 2 high. We are giving the speed of pin 2 as 150 and pin 3 is 0. Similarly, we will make pin 4 high. So this is the coding for obstacle avoider. Now you have to select your Arduino Nano and then select the From here you will get the port number, so select the port and then click on upload. Your code will be uploaded to the controller. Output of the obstacle avoider.